Hello and welcome to this eCognition Deconstructed video. Today we're gonna talk about distance map. That's a very nice algorithm to calculate the distance of each pixel to objects belonging to a certain class. That means that each pixel gets a value which depicts the distance to the outline of a certain object that you define in the domain. Because this is an essential feature of this algorithm, I'm going to emphasize this one in the second bullet point. Again, the distance is calculated to the image object boundary and not the center of the image object. Okay. We are using 8 neighborhood calculation, which allows diagonal distance measurements. And usually you select a class to which you want to calculate the distance to. But if you leave that field empty, it's simply going to calculate the distance of each pixel to its next image object border. The output is a raster layer. Each pixel has a value which represents the distance to the boundary of the image object that you've defined. Here you see the possible result of the distance map. On the left hand side, I simply calculated it in all image objects. So I calculated the distance to the small image object in all image objects. On the right hand side, I limited it in the domain. I said only calculate distance within that large image object and do not calculate the distance within that squared image object in the center. I simply use the domain to define this and I get -1 values in this squared image object here. You also can choose if you want to use the current or the latest version of this algorithm or the version 8.8 algorithm. And actually, if you use the version 8.8, you get different results compared to the current or the latest one. You see here the same example that I showed you on the previous slide. So we find in the domain that it shouldn't calculate the distance within that squared image object here that is blackened out here. And the result looks different, right? On the left hand side, you see that the distance right behind that obstacle is higher, because it has to flow around our obstacle, right? In the latest version, it's simply going through it and you get the direct distance from each pixel to your seed. Another small difference is that if you use the version 8.8, it only calculates the distance within the image object that directly touches the distance to objects, so your seed objects. You see it on the right hand side. I did a small chessboard segmentation and you see that only the distance is calculated within the image objects that are touching my seed object or the distance to object. Let's have a look at a few examples, and I'm actually quite excited because I think these examples are stunning. What we see here is a RGB near-infrared image, and I have 2 vector layers as well. One representing the buildings and one the roads. And what we want to do is now calculate the distance from the buildings to the motorway and then reclassify the buildings based on the distance to the motorway. First, I did a segmentation using the thematic layer and also classified them based on the information of the thematic layer. So we have 2 classes at the moment, motorway and the buildings. In the next step, I want to calculate the distance map. The algorithm is called distance map and the domain is image object level in this case. Level 1, that's the level I created. Distance to motorway. I want to calculate distance to a motorway. Then we have 2 different calculation methods, precise and fast. I'm going to go for the precise one. And down here, the modes, you have the current version, also the version 8.8, right? And the latest version. So be aware of the differences, right? If you forgot it, please go back in the video and check again. After execution, we have a new raster layer that you see on the left-hand side. I called it distance map, okay? So that's our final result. And we should have low values quite close to the motorway and higher values that are further away from our motorway. And that looks actually how it should look like. And actually in the next step, I want to calculate or create buffers based on this distance map. So I simply use the multi-threshold segmentation define different thresholds for my different buffers, execute this one, and this will automatically create my buffers. And here you see the result. So we have different classes based on the distance to the motorway, so different buffers. I gave it different colors, orange to yellow, and now you see we have created different buffers and also image objects based on this distance information. That already looks pretty good, but what I want to know is how many buildings are within my first buffer and how many are in the second and third. So what I do, I use simply assign class and I reclassify my buildings into different building types. And I'm using a feature called minimum pixel value. The minimum pixel value gives you the minimum pixel value of a certain layer that you define within your image object. Using this feature actually will classify also buildings that are, let's say, mainly outside of the first buffer. But if 1 pixel is within the first buffer, it will be classified into this buffer. Okay, because I'm using the minimum pixel value of this image object. I created 6 different 6 classes, yes, based on distance, and the result looks something like this. And here you see this result of using the minimum pixel value. So the buildings that are mostly in the next buffer, but at least 1 pixel is in the closer buffer, they will be classified into the first buffer. So that looks pretty nice. Down here I also depicted the number, so how many buildings have been classified into this class A, which represents the first buffer, B the second buffer, C the third, and so on. Let's have a look at another possible application of the distance map. In this case I wanted to calculate a conceptual outline or create a conceptual outline based on the distance map calculation. So again, I have the buildings here and I want to create an outline that depicts urban areas, right? So I first do the segmentation and classification of the buildings, and then I calculate the distance map, and I actually remove here the class in the distance to. So it's going to calculate for each pixel the distance to the next image object outline. After the calculation, let's have a look at it and see if it worked and if the result looks as expected. Let's check. And this is the result of the distance map, and that looks quite promising. Now again, I use the multi-threshold segmentation and I define a distance of 75. If it's lower, it's going to be classified as urban. And also I defined a minimum object size of 50,000 pixel. That means it only creates an object where I have a few buildings and not just one single building. And that's the result. Then I apply some pixel-based object resizing to smoothen the outline that I just created. I also remove the small gaps here and merge classified. Yeah, let's add a remove objects algorithm to remove small image objects and closing these gaps within the urban areas that are smaller than maybe 10,000. Okay, execute this, and that removed small gaps that I had before. Yeah, so now we have an urban area. Last but not least, I want to show you the eCognition version 8.8 result, how you could use this one. Let's assume we have these buildings and we want to calculate the shortest path from one point to the other. And actually then it makes sense to use this version 8.8 calculation implementation within eCognition, because this one calculates the distance and is flowing around the obstacles, right? The latest version and the current version, they're going straight through the obstacles. Version 8.8 is flowing around. So what I have to do is define a goal, or what I'm doing here. I wrote a rule set that's calculating the shortest distance from a start to goal image object, and red image objects here are our obstacles. So I classified a goal and I'm using distance map calculation, and I say here in the domain only calculated in unclassified and calculate distance to goal. And I'm using the eCognition version 8.8, and that will result in a distance calculation only in the unclassified image object, and it will flow around my obstacles instead of creating a distance map that's calculating the direct distance, right? Now you see bottom left corner we have our goal, and that's the distance map. And now I'm simply gonna classify one image object where I want to start, and I want to have the shortest path between my start and my goal image object. To do so, I'm using an algorithm that we're gonna do a video on in a few months. It's called image object fusion. And the settings that I'm using here defines that it looks at the start image object and it looks at the surroundings, and then it's gonna grow into the one with the shortest distance, right? And I created a loop, so it's gonna loop each time and grow further until it reaches the goal, and then it stops. It reclassifies it as shortest track and it stops. That's one example here. Let's have a look at another one that I created. So now we have the goal down here, different position. Let's classify start and then simply execute this loop again. Let's start from here, execute this loop, and then it's gonna grow and use the shortest path. Right, makes sense, right? Let's create another one and see. That's the shortest path. And maybe one here in the center. I hope you understood what distance map can do for you, and you may be interested to try it out yourself. Go ahead. And I hope you enjoyed this video. See you next time.